Okay. Okay. So in the previous class, we have discussed an example on push down automata and acceptance of a string by push down automata. Uh, am I audible?
Yes, sir.
Yes, sir.
Okay. Yes. So, so there we have discussed an example for accepting designing a push down automata to accept the language of the form a power n b power n such that n is greater than equals to 1. Therein I have also given you an assignment to design a push down automata that will accept a language of the form L equals to a power n b power 2n and n is greater than equals to 0. So there are two ways to design the automata or a push down automata for accepting a language of the form L equals to a power n b power 2n such that n is greater than equals to 1. So first looking at the string that belongs to such category. So there are few string that belongs to this particular categories, and these strings are of this kind. That is a language that wherein there are n number of a's followed by twice the number of b's as the number of a. Okay, so here the string would be ABB or AABBBB. If there is one A, it is followed by two B. If there are two A's, then it is followed by four B's. If there are three A's, they are followed by six B's and so on. Right. So we have already seen the logic for A power and B power, and what we used to do, we used to push A for all the A's. It is being read at a particular state. If you are reading A, then you were pushing A onto the stack. As soon as you start reading B, you were popping those A from the top of the stack, right? But over here, we want that there should be twice the number of B's as that of A, right? So in this case, if you will push a single A for A being read, it won't solve the purpose, right? So instead, what we'll do, in order to match the number of B, what we'll do, whenever one A is read, we would be pushing 2A on the stack, right? So whenever one A is read as input, we will be pushing two A's on the stack, right? So to do that, we'll write a rule of the form like this. We'll design a push down automata by using transition diagram, and therein we would be writing the transition rules, right? So there would be initial state. So this is the initial state, and in this initial state, if I get A as the input, then the configuration will be, that is the first or the initial configuration of push down automata is always the initial state, the first input symbol and the top of the stack, that is Z0. So always the first input will be Q0 A Z0 because the input is A and the top of the stack, initial top of the stack is Z0, right? So if there is a configuration wherein there is Q0 A and Z0 as the input combination, then the next state will again be Q0 and we will push two A's onto the stack for matching the twice number of B's, right? So for 1A, we'll push 2A in this way. Like if A is in the input, Z0 is on the top of the stack and Q0 is the current state, then we will go to the next state as Q0 itself and replace this Z0 with AAZ0. That is above Z0, we will be pushing 2A's, right? Now here, then in the next, when the next input is there, the automata will again be in Q0, but the input can be either A or B, and the top of stack will be A now, right? Because this A is already pushed onto the stack. So the top of stack will now not be Z0, but the input can be A or B, right? So if the input is A, then again for that A, we would be pushing twice A on the stack, right? That is 2A. So for that, we'll write a rule like this. In Q0, if I get A as the input and A is on the top of the stack, what we'll do? I'll push two A's. This is the third A, which is nothing but the earlier top of the stack. So we are pushing this two A's, and this A is this one. Okay. So above it, we are pushing two A's. Okay, so this will be the case wherein we'll read all number of A's, and for those A's we will be pushing twice the number of A's on the stack. So if you have read a single A, there will be two A on the stack. If you have read two A's, there would be four A's on the stack, and you will be staying in Q0 itself. As soon as you start reading B, what will do? Because now the number of A's which are there on the stack, that many number of B should be read by the push down automata. So in Q0, as soon as I get B as the input, this means that all the A's are read. Now to mark that all the A's are read, and now further there should be no A being read. So we'll change the state, right? So for the first B we are reading, what we'll do, we'll pull up a equivalent A from the stack, right? So and change the state. So if B is the input in Q0 and A is on the top of the stack, what we'll do, we'll pop that element. So we have replaced it with epsilon. So we'll pop the first A. Okay, so this was A on the top of the stack, and now we are replacing this with epsilon and changing the state to Q1. Now in Q1, we cannot get A as the input, right? Therefore, we have moved to Q1. So in Q1, you can get B as the input, only B as the input, right? Or epsilon, right? So in Q1, if B is the input, and again the top of the stack should be A only, right? If B is in the input, then the top of the stack should be A only. So in Q1, if you get B as the input and top of the stack is A, again you will perform pop operation. So this will go on like this until all the B's are popped, right? So if sorry, until all the A's are popped from the stack and all the B's are read. So if there is a configuration that is Q1, the next input is epsilon and the top of the stack is Z0. This means that there are twice the number of B's as compared to the number of A's, because we have pushed twice A and we have popped those A for the equal number of B, right? And if all the A's are removed from the top of the stack and there is Z0, this means that we have read B equal to the number of A's, that is twice N. Okay, so we'll again traverse to the next final state. That is, if epsilon is the input and Z0 is on the top of the stack, we'll keep Z0 as it is and move to a final state. So this automata will accept the string of this particular form by final state. Now, if you want to accept it with in empty stack, just instead of this Z0, make it epsilon, and you can keep it as QF or you can make it a non-final state. Right? Is this clear?
Yes, sir.
So this is one logic, and the machine will be represented in this form: m equals to the q, which is the number of states or all the states. This is sigma, which is the input symbol. This is gamma, right? Sorry, gamma. Yes, gamma, right? Capital gamma. So this is Z0 and A, which is nothing but stack symbol. This is delta, that is transition mapping. This is initial state Q0, Z0. Again, it should be capital. There's a mistake. Okay. As I have used over here as capital, so it should be capital. If I would have used small, then it should be small, right? So this should be capital Z0, and QF is the final state. So this is the machine format, and this transition diagram shows acceptance by final state. So this PDA accepts the string of the form A power n, B power 2n by final state. So in exam, you might be asked to design a push down automata for a particular language that accepts the string using final state. In this case, you would be designing this kind of automata. If it is asked to design by acceptance by to show acceptance by empty stack, then instead of this, you would be writing the other rule. Only this part would change. It would be epsilon comma Z0 oblique epsilon, and this would be a non-final state or final state. You can keep anything, but it should be empty stack. Now there is another logic, like we did in the previous example itself, right? Like, why should we push two A's? Someone might think that why to push two A's for a one A being read, right? So in that case, what we can do, we can this one way is that we can push two A's. Another way is that we can push a single A, but when we will read a B one time, for one B will traverse, for the next B will pop. For the next B will traverse, for the next B will pop element from the stack. Traverse means we'll keep the stack as it is. We'll not do any operation on the stack. Right. So that kind of logic can also be used. You can show acceptance of any string by using this push down automata by using id, as we have seen in the previous class. So you can consider any of these string and try to show the acceptance or rejection of these strings by that particular this particular push down automata. The next way is to design is that we'll push the number of ways we read. Then for B, for the first B being read, we will traverse. For all even number of B's in the sequence will pop. Right? For first B will traverse, for second B will pop, for third B will traverse, or traverse in the sense we'll keep the stack as it is. We'll just read the symbol input and move ahead. Right? Then for the next B, that is fourth B will pop. Fifth B is there, will traverse, and for sixth B will pop, and so on. Right? So that it would match the twice number of bees, like this. So we'll design it in the same fashion, but here instead of pushing two A's, we'll push a single A. So the first configuration is like this, that only. So in initial state, if I get A as the input and top of the stack is Z0, I'll push a single A on the stack. Right? If the next input is A and the top of the stack is again A, so I'll again push A on the stack, single A, right? Like this. So whenever there is A as input, I am pushing it onto the stack, an equivalent A. There is a single A. Now, after reading all the A's, there would be B as the input, right? In this state itself. So that would be your first B. So what I said, whenever I'll read a first B, I will just traverse. Traverse in the sense, I will keep the stack symbol as it is. Like if it is Z0, I will let it be Z0 only. I will not push anything, neither I will pop. So for traverse, this Z0 will be replaced by Z0 itself. Instead of for pushing, what we do, we add additional symbol and write the same symbol like Z0. If we want to push, I have written AZ0. But when I want to pop, I write Z0 oblique epsilon because I am popping that element. But when we want to traverse, we'll write this Z0 oblique Z0 itself. That means we are neither pushing nor popping any element, we'll keeping it as it is. Right? So whenever odd number of B's are read, we'll traverse. We'll keep the stack as it is. Right? Traverse the input string. Okay, so if in Q0 I am getting a B, I will, and there is A on the top of the stack, I will keep this A as it is and move one step to the right, the input pointer, right? So I'll go to a new state. Now I am moving to this new state because I have started reading B and now I don't want there should be any A as input, right? Therefore I change this state. Now in Q1, you will get second B, right? You cannot get a, but whenever you will get a B in Q1, that would be your second B. Am I correct?
Yes, sir.
Yes. Right. So you need to change again a state, because if you will add a self transition over here, so this will be like it can read a second B and it can read a third B, then it can read a fourth B, and again it would be popping. But what we want that every time for the second B it should pop. So for that purpose, we'll be changing the state to a new state from Q1. If I get B as the input and A is on the top of the stack, so that would be my second B, and I will pop that element. That is, I will pop A from the stack like this. B on A will be popped from the stack, and I will move to this new state. Right. So I hope you have you know how we have designed the push down automata, sorry, finite automata for accepting even number of zeros or even number of ones. We used to start from initial state, go to other state, and come back to the initial state. So this will read even number of zeros or even number of B's, right? So here, this is the second B I have read, I have popped. Now, the next B that I would be reading should not pop anything from the stack, right? Okay, because that would be the third B. So in Q2, if B is the input and A is on the top of the stack, what I'll do, I'll keep this A as it is, but I should go to a state such that when from that state if I read another B, I should be able to pop, right? So I will add a transition from Q2 on B to Q1 and let the stack as it is, that is A, it would be A only. Then in Q1, if I get the next B, so that would be the fourth B, right? So this is first B, this is second B, this is third B, and when I'll get another B in Q1, that would be the fourth B. And as I said that if it is or even number of B, then it should be pop. So it will again pop, right? So every time the second B is read, an equivalent A is popped. Okay. So in this way, we'll pop all the A's if there are two B for that particular A. At the end, you will come in this kind of configuration if the string matches this particular scenario. That is, number of A's is equal to half the number of B's, right? So at the end, you will get a configuration like this epsilon z0, and you will move to a final state, or you can empty the stack and be in any other state. So this will accept the string of this particular format. So we'll see an example for this particular automata. This is simple. This is as your previous one itself. For this, I'll show you acceptance for a particular string. So this is its representation. Whenever there is a question in exam to design a push down automata for a particular language, you need to do three things or four things. First is you would be writing this L that would have some string that matches this particular format. The first step is to write L, which is equivalent to this. So it would consist of the strings of this particular format. Second step is to design the push down automata. So design of push down automata can be in form of transition rules or transition diagram or transition table. It is better to design a transition diagram, right? The next thing that you would do is you will write this machine format, that's tuple format of this machine for this particular machine. So it is written like this. Here there were three states, so I have mentioned three states. Here there are four states, I have mentioned four states. Right? So Q, sigma, gamma, delta, Q0, Z0, F. So this is the representation. This is the third step. So you can write this above this or below this, but these three things you have to write. And the last thing that you need to write is to show acceptance or rejection of a string. Both, one example. Right? If the question is for 3 marks, then this much is sufficient. If it is specifically given that you have to show a particular string, acceptance of a particular string, then you need to show for that particular string. But if it is not given and the question is for 5 or 6 marks, then you need to either show acceptance or rejection of a string. Generally show acceptance of a particular string. Right? So this is the last thing that you need to do. So these four things are to be done: first, second, third, and fourth. Right? So I will consider a string A, B, 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 B. So there are two A's, which is followed by four B's, twice the number of A's. So initial configuration will be initial state, and top of the stack will be Z0. So in Q0, if you get A as the input and top of the stack is Z0. So if you look at this automata, then in Q0, if A is the input and Z0 is the top of the stack, what we used to do, we used to push A on the stack. So it becomes AZ0. So over here in the next step, it would be Q0. Then this A is read, so I am moving one step ahead. So now the next input will be A, B, 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 and I have pushed A on the top of the stack. Now again in Q0, I get A and top of the stack is A. So Q0, A. If you look over here, so the transition from Q0 on A and A as the top of the stack, A as the input and A as the top of the stack, I'm again pushing a single A on the stack. So now the top of the stack will become two A's like this. And the remaining string is B, 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 B. Now in Q0, I am getting B as the input and A is on the top of the stack. So this is the first B. So in Q0, if B is the input and A is on the top of the stack, what I'll do, I'll keep this stack as it is and move one step to the right. Right, move the read head. Simply I'll move the read head and let the stack be as it is. So this stack will be like this only, A is Z0, but the input string will now change. So the input string is remaining, that is B B B, and I have moved to a state Q1 because this shows that I have started with B. Now in Q1, if I get a B, so this will be the second B for which I was looking. And for this second B, I need to pop an element from the stack. So there is a rule, Q1 on B and A on the top of the stack will pop the element from the top of the stack. So for this B, which is the second B, an equivalent A will be popped like this. So the remaining string will be BB and A on the top of the stack. So now I am in state Q2 because here I should remember that I have popped A equal to 2Bs. Right. So in Q2, now if I get B as input and A on the top of the stack, so this indicates that again this is the first B because we have to pop A for two Bs. So among that, this will be the first B. So for this, we'll simply traverse, right? So in this case, if Q2 is there and B is the input and A is on the top of the stack, we'll simply traverse. So this will be as it is, and we have read this B. Now in Q1 again, if you get a B in Q1, this indicates that this is the second B for which we need to pop a A. So we'll again see the combination in Q1 B. If A is on the top of the stack, we'll pop this A and move one step to the right. So now I will be again in Q2 and epsilon, because I've read this B and I've popped this A, therefore top of the stack is Z0 now. Okay. And now if I've reached this configuration, that means I have accepted the string. And in Q2, if I get epsilon Z0 as the combination, then I will let this Z0 be as it is and move to a final state. Or I may pop this Z0 and go to any other state, any intermediate state. Or you can be in Q2 itself by adding a self transition, just by replacing this with epsilon. So that would be accepted by empty stack. So in this way, I'll reach a final state, right? As I have read the string completely and reached a final configuration, therefore, this string is accepted by the push down automata. Now, same kind of acceptance can be shown by this. So, if this question is there, either you can design this push down automata or you can design this push down automata. Either of the two is correct. Okay, you may design any of these two. It's your choice. But if it is given to show acceptance by final state, so you will be drawing any of these two. And if it is given that to show acceptance by empty stack, then you need to modify it. And how to modify, we have seen in the previous class and I have explained today also. Okay. So then uh, this is what you need to do. Again, try at your home. I have solved this, but I want you to try. So you need to design a pushdown automata that will accept the language a power n, b power 2n plus 1. Now here there is additional one. This language is equivalent to this. That is, there will be n number of a's. Then you read a b, that is traverse a b, and then there are twice nb. That is, one additional b is there. Or you can simply accept design a pushdown automata that will accept this particular language, and from them that you can read a b and go to a particular configuration from where you can accept a string. So first read this particular format and then traverse a b. Traverse means you will not perform push, neither push nor pop, just you will traverse, right? Or you read n number of a's, push this n number of a's onto the stack, then traverse for a b, right? And then for twice b, that is always the second b, pop it from the stack. Try to design a push down automata for this, and if you are able to do, very good. Otherwise we'll discuss it in next class.